My name is Christoph Schwitzer. I'm Head of Research at the Bristol Conservation and Science Foundation based at Bristol Zoo. And I'm also, with my second head on, Secretary Executive of an association called the AEECL, the European Association for the Study and Conservation of Lemurs. And in that function I'm working here in Madagascar in our field research station in the Ankarafa forest, doing research on critically endangered lemur species. So I have the opportunity to travel here once a year for a couple of weeks and make sure that it's all working fine. We have arrived in Normandia today, which is the main village on the mainland bit of the Samalasa National Park. AECL has been working on community-based resource management with local villages in the national park. We are meeting the villagers and talk to them about the annual program of the association, what we are going to do and how we are going to do it, and ask them for their support. Basically what we want to achieve with this whole program is that we want to take pressure off the remaining forest fragments, of the remaining habitat for some critically endangered lemur species, by improving the livelihoods of the local communities surrounding the core areas of the national park here. The association itself has been working in this part of Madagascar for the better part of the last 20 years. We were the first one who actually rediscovered the blue-eyed black lemur as a proper species, and since that time we actually as an association have tried to get the area here under official protection, which succeeded in 2007 with the official establishment of the Samalasa Ilradama National Park, where we are now working at. Samalasa National Park is a very, very special biogeographical area. When you look at a map of Madagascar, you have the Sambirano rainforest region spanning all the island in the north, and you have the western dry deciduous forest region on the west coast further south of here, and we are right in the middle of that, meaning that we get the rainfall from the rainforest region, but we get the temperature from the dry forest region, which makes this forest very, very special with its unique assemblage of lemur species that are found nowhere else at the moment, or that have never been found anywhere else actually.
I'm Melanie Seiler. I'm from Cologne, and I'm studying a newly described species of lemurs, small brown lemurs, potentially critically endangered, at the University of Bristol for my PhD. And I'm just here to have a look on basically stuff like ecology and social behavior. Are they living in pairs or in groups or solitary? What tree species do they prefer? Where do they sleep? How active they are during the day? Are there differences between differently degraded forest fragments? We are now in our last primary forest fragment that unfortunately burned down in 2007. We found a new lemur at the moment in a tree hole. And as you can see, it's not the best tree hole because a lot of holes and a lot of opportunities for birds of prey to just catch the leapy. But if we disturb it now, it would probably move because it would realize that, okay, it's not the best place to stay here and should look for a better one. They can see me. So it's a nocturnal species, so of course it's very active during the night and very fast, and it's really hard to follow them. But during the day they used to rest, but they don't really sleep. They are very vigilant because of the raptors like hawks or fossas, so they can't really sleep but have to take care all the time. From what I observed the last year, I suppose that this lemur species seems to be solitary. They always sleep alone during the day. I only saw once a pair, but I think it was a mother with a maybe 1-year-old child because the one was quite small. And during the night they meet, but they yeah, it's more like feeding in the same tree or just about 20 meters seeing each other, but they don't really interact. That's my impression at this point.
My name is Johanna Rode and I'm from Germany, and currently I'm studying a master in primate conservation at Oxford Brookes University in England. I went to Madagascar to study the northern giant mouse lemur, and the scientific name is Mirsa sasa. And this is a species that was described in 2005, so not long ago. It's the size of a squirrel, I would say, and it's a very quick animal. It can run very fast and actually almost nothing is known about it. It's just there's some information about its distribution, also something about the conservation aspect, what the status is, but actually not more. For example, about ecology, there's almost nothing known, and that's what I want to find out here, more about its ecology.
The field station here in Ankarafa Forest has been established in 2004. Since then it has evolved quite a bit. So our program manager here in Madagascar has planted several nice species of tree, bananas, papayas, which we can harvest ourselves now. We have several outbuildings now with possibilities to put up tents for students, essentially, and for other field guides that we need to work here. We have a river running through camp, which is really nice. When I first came here in 2003 to assess the area, I went for 2 months around the Samalasa Peninsula looking for potential places to set up a research station, and this was literally the only place where it was possible because of the proximity to water. It's a very nice river with a waterfall where we can shower and also use the water for drinking and cooking. And also because of the proximity to the forest fragments, to the lemurs, because you don't want to walk for 4 hours there and another 4 hours back every day to actually do your research. That would tire you out and you wouldn't really be able to collect lots of data. So this is really an ideal spot, and we are very grateful to Madagascar National Parks to enable us to continue our research here.
It's a very basic living here because we're just in the middle of nowhere, kind of. But we've got a kind of a house, but it's more a storage room. We basically eat rice and beans, and rice and beans, and rice and beans. Or in the morning, rice and rice. And yeah, there's no doctor around or something, so we have to care for all our medical stuff and have to know what to do in situations where somebody has malaria, what's quite possibly here and I had last year, or somebody breaks a leg or whatever. It's not the life for everybody, I guess, but I like it.
The power that we are currently using to run the research station here is solar power from the sun. We used to have 3 solar panels of 50 watts each. We are currently upgrading our solar power system and getting 2 additional solar panels. And we hope to be able to meet all the students' electricity needs then. Electricity needs have gone up with the more sophisticated research that we are doing here. We are now using radio tracking for several lemur species. We are recording vocalizations of lemurs with all sorts of tools that need to be recharged every day. So this is why we are currently upgrading the solar power system.
Number 8. Okay, this is a tree hole where I observed the lepi last field season. but nobody home. And instead of a lepi, we've got bees in there now. That's kind of a shame because treehouse are a battlefield here. The bees want them, the tanrecs want them, the little lepis want them, the fat-tailed dwarf lemurs want them, so lots of stuff in treehouse here. First of all, I'm going to describe first the forest fragments the animals live in. Then I'm doing day observations and checking if there's a difference in the level of activity between, first of all, the fragments and between different resting sites, because they're resting either in tree holes or in trees itself, in tree tangles. We found already a difference. They are more active in the tree holes, and I suppose it's because it's more open, because there's no canopy above the animals, and so they have to take care that no birds can see and catch them. And during the night I'm having my GPS and my Marantz recorder to get the vocalizations, and we track them. We radio color 12 of them this time to follow them during the night, because it's absolutely impossible without tracking, because they're so fast, and in the canopy you just lose them after 2 seconds. And we take the GPS points whenever we see it, and then we can create the home range for the animal. And just write down every behavior we see, like feeding, foraging, resting, maybe meeting other leafy lemurs, locomotion, jumping or walking, everything. It's very unusual. Can you see that she can turn her head complete around like an owl?
Beautiful.
It's unusual that it's got dirt at its face. It's the best indicator that something's wrong. Yeah, here they would directly clean it.
Very unusual, and only today, and I don't know.
We're here at the tree hole where we saw the individual last night to check if it's alright or if it's dead or whatever, because of its strange behavior yesterday. But unfortunately it's just not here, and we can't find it around, so we don't know if it's okay and just change its sleeping site, or if it really was maybe eaten by a fossa. So yeah, we check that again maybe this night or tomorrow and hope that it's fine.
Since the species is nocturnal, it's quite difficult to follow these animals and actually to observe them. So what I want to do is to give them radio collars and track them with the help of these collars during the night. So we'll go to the forest with an antenna and a receiver and then try to follow them. Of course, before I attach the collars, I have to capture them. Then I want to observe its behavior, what it's doing during the night, and also maybe what food do they like, what do they eat, how large their home range is, which tree species do they like old trees or younger trees or dead trees or trees that are still alive. The problem with this species is it's currently listed as data deficient on the international red list, and that means that there's not enough information to assign a threatened category. And my aim actually is to get more information about the species to be able to actually red list it. And that would help, of course, in conservation measures. And the other aim I have is to collect information about which habitat it prefers. And with that information we can design conservation plans in a better way, in a more efficient way, because we actually know which tree species we have to plant and which areas we really should protect to be able to keep the species and not to lose it.